Okay, here we have a summary of what you need to know to graph quadratic functions. Here are 3 problems. Okay, now you all been working on these problems, so everybody in class here knows what these problems are. If you're not here, you need to work these problems. Preferably without looking back at the summary I gave you. But now we're going to move to the summary, and hopefully everybody who's watching this has done their best to work these 3 problems. Okay. And people having difficulties of one sort or another. So here's what you know about a quadratic function. Now we want to graph y equals x squared plus 5x minus 6. Now I didn't write the quadratic function. Yeah, I did. I mean, the quadratic formula, here it is, zeros at x equals this, okay? So what are we going to do? We're going to, okay, let's find the zeros. Axis of symmetry. X and y-intercept. With the caution that you don't always get zeros, because if you end up with a negative under this radical, you're not going to have any points on the x-axis. And the graph will either be above the x-axis opening upward or below the x-axis opening downward. If it's opening upward and it's below the x-axis, it's going to go through the x-axis and it's going to have zeros. If it's opening downward and it's part of it's above the x-axis, it's going to go through the x-axis again, and you're going to have zeros. All right. And the negative 4ac there kind of takes care of that in a way that we're not going to try to detail. Okay. At least negative 4ac compared to the b squared. So zeros at x equals, and everybody knows how to substitute here. B is 5. So everybody got that part right. Make sure I've got my numbers right. Okay, so everybody plug these numbers in correctly. Now there's always a tendency to not be careful enough about the negative signs, but you're going to have a negative of this product, and this product is negative because of the negative 6. So you're going to have a negative of a negative, and you're going to end up with a plus here. So that's going to be negative 5 plus or minus square root of 49 over 2, which we could write as negative 5 halves plus or minus 7 halves. Because the 2 divides the 5 and it divides the 49. Remember, dividing by 2 is like multiplying by 1/2, so this is just an instance of the distributive law. Well, you actually see 2 things here. Here are your zeros. Well, these 2 things are your zeros. Right here is your axis of symmetry. It's halfway between the zeros. It's 5 halves, negative 5 halves plus 7 halves is on one side of negative 5 halves. Negative 5 halves minus 7 halves is an equal distance on the other side. So negative 5 halves is halfway between your zeros. you really want to understand that because it makes it a lot simpler to remember what to do and to think about these things. Okay, so anyhow, we got our zeros. And we can begin making a graph. I haven't given myself a lot of room here, but try to squeeze it in. Your zeros then, well, that would be negative 12 halves, which would be negative 6. So on the line where x equals negative 6, you'll have a 0. And on the line x equals 1. You'll have a 0. And from this, you also get your axis of symmetry, which is at x equals negative b over 2a. But if you've plugged your numbers into the quadratic formula and simplified it like this, you already know what negative b over 2a is because that's where the negative 5 halves came from. Okay? So you don't have to have a separate formula for the axis of symmetry. And if you can look at this and see that this is the axis of symmetry and know why, you have a deeper understanding. Now, if you just want to memorize, more equations than you really need, when you could do little extra work and understand it if you can, because not everybody easily understands what I'm telling you about where the axis of symmetry is, then it's to your benefit to do that. And you should consider doing that rather than cluttering your mind up with a bunch of different formulas. Okay, so anyhow, there are your zeros. So we already have information about this graph. What other information do we have about this graph? Well, the axis of symmetry, well, let's sketch that. And since I put the axis of symmetry in this different color here, I'm going to put it here. It's got to be halfway between your zeros. So here's your axis of symmetry, and it's what? It's x equals negative 5 halves. Now note, if I add negative 6 and 1, I get negative 5. So if I add these two and divide by 2, which is what you do to find what's in the middle, if you want a number right in the middle of two numbers, you add those numbers and divide by 2. You get the average, mean average. And you get negative 5 over 2. So it agrees with this and what I wrote up here. How do you determine then the coordinates of the vertex? You know it's on the axis of symmetry. Well, I say it's at y equals f of negative b over 2a. And let's see what that constitutes. It's f of negative 5 halves. Well, f of x is your quadratic function. In this case, this is your f of x. And if you want to talk about the function, if you want to talk about the characteristics of this thing, it helps to remind yourself that we can call this function f of x or g of x or h of x or Billy Bob of x. Okay, we can call it anything. We can give it any name we want. Okay? So we gave it the name f of x so we can do this. Okay? Now I hadn't given it the name f of x when I wrote this originally, but then I realized I wanted to tell you that the name of this function is f of x so we can use the function notation. Okay, well, what's f of negative 5 halves? Well, we just plug negative 5 halves in for x. X has been replaced by negative 5 halves. We replace all the x's by negative 5 halves, just like we do when we're making a composite. So that's negative 5 halves squared plus 5 times negative 5 halves minus 6. Okay, well, that equals 25 fourths. And this equals 25 halves, and you have minus 6 there. Well, this ends up being negative 25 fourths minus 6. Negative 25 fourths minus, well, 6 is 24 fourths. It's negative 25 fourths minus 24 fourths, and that is negative 49 fourths, which equals negative 12 and a fourth. So we know that the vertex is down here somewhere. We haven't put a scale on our y-axis yet because we didn't know what numbers we were going to run into. But now we know that we're going to have a horizontal line representing y equals negative 12 and a fourth, which runs into what I have. Let's box it off. And our vertex is here. The other thing we know is the y-intercept, which is it. Zero, f of 0 means we plug 0. F of 0 means we plug 0 in for x, and we get 0 squared plus 5 times 0 minus 6. And of course, you're just calculating it and know that you're plugging 0 in here. You see that these numbers are both going to be 0, and you're just going to end up with negative 6. So there's our vertex. It's at 0, negative 6. And we can, okay, if this is negative 12 and a quarter, that's just about the same as negative 12. So just kind of go about halfway between the x-axis and the line y equals negative 12. We get the line y equals negative 6. And now we can sketch a parabola. It comes down here, comes up through here. And I wasn't even looking at this point. I just tried to make a smooth curve. It bottomed out here and went through here. And look, it went just about right through y equals negative 6, didn't it? It's not because I have any special skill that you wouldn't have if you'd made enough constructed graphs of the scoring function, which some of you certainly have. So at least the people who are in my class, and everybody here today is in my class, and some people are missing, but so I can kind of mention that. Now in my class, we're going to do this within a window. We're going to do it within a 4 by something window, and we're going to determine a few things that are a little harder to determine if you do it algebraically, but we're also going to do it with algebra. Now, I'm raving on about that, but you don't necessarily know what I mean at this point, so let's just move on here. Uh-oh. I thought I'd washed all these boards, but that one didn't get washed. So I'm going to move this over here. And this one's about worthless. I mean, it's worthless for the present purposes. It's plenty of value. I'm going to move this over here. Okay, now I've got some room to work. And let's look at the next question. Okay, so constructing a quadratic graph is really straightforward. You just have to practice it and think about what you're doing. Because if you understand what you're doing. If you do it enough and think about what you're doing, then it begins to dawn on you, okay? And pretty soon it hopefully becomes locked in pretty well. So that when test time comes around, you just have to do a quick glance at it to remind yourself, okay, that's going to stick in my head. Now I'm going to be able to do this, okay? That's how you need to prepare. And there will be another test in a couple of weeks. Well, be a little longer than that in my classes. Other classes have different schedules. Um, okay, formula for the toolkit scoring function, vertically stretched by factor 2, horizontally shifted -3 units, vertically shifted -5 units. You need to understand those shifts. You need to understand the explanations I've given you, the explanations in your book. But it just comes down to this. Y equals AF of X multiplies all the values of f of X, all the Y values you get for f of X. Let's write it this. I've never read it. Okay, Y equals f of X gives you Y values. It might be hard to read from back there. Kind of at the edge of what I can do here. Okay, Y equals f of X gives you your Y values. Y equals AF of X multiplies those Y values by 2. What happens if you multiply the Y values by 2? You need to understand this. Every point gets twice as far from the x-axis. One way or another, you need to understand that that's how you vertically stretch a function. If every point gets twice as far from the x-axis, then a function that's graphed within this window is all of a sudden graphed within this window. So if you have a scoring function graphed within this window, you're going to get a scoring function that's graphed within this window. It's going to be twice as skinny. I didn't draw it very well, but you get the idea. And your text shows you that in other ways. Videos explain it in other ways. Make sure you understand why multiplying a toolkit function by any number A moves everything, A vertically stretches it by a factor of A. Now, if A is negative, it also flips it around upside down. So this, if it was a -2, you'd stretch it by 2 and then flip it over. So now it's opening downward. So do everything you can to understand those things. Okay, then. Say y equal AF of X plus K adds K to all the Y values of AF of X. Then I'm not going to give you a descriptive statement of why this is so, but I will say that if h is a positive number, then to get same value of y, x has to be h units bigger. Now, that's demonstrated many ways in the homework, in the problem sets. And as you're going to see it, maybe you're already seeing it, depending on whose class you're in your Math 161 class. So we're trying to understand this as best we can because this is a big hurdle for people. So it takes some real doing. Okay, so anyhow, so I say that this replaces x by x minus h, which shifts points h units in the x direction. That is horizontally. So that's a summary of what your various shifts and stretches do. Now, here we have toolkit scoring function, stretched by vertically stretched by factor 2, shifted -3 units horizontally and -5 units vertically. Okay, so the problem we start with the toolkit squaring function, y equals f of x equals x squared. We the vertical stretch factor A yields y equals a f of x equals 2 f of x. Now we could write 2 f of x. We could write that as 2 times a quantity. We're not going to do that, never mind. Okay, it gives us 2 f of x. And that would be 2x squared. I guess that's worth writing out. Dealing with limited space here. But remember, f of x is x squared. Then horizontal stretch. Uh, Vertical stretch k then implies y equals a f of x plus k equals 2 f of x. And I wanted to actually number in here, vertical shift -5, that's k. K is -5. And I didn't write this down exactly the way I wanted to. vertical stretch factor 2 yields 2f of x because a equals 2. Vertical shift -5 yields 2f of x minus 5 equals 2x squared minus 5 because k equals -5. And that horizontal shift of -3 means we're going to have y equals a f of x minus h plus k equals 2 times x plus 3 squared minus 5. And I'll just make a note that h equals -3. So x minus h equals x minus -3 equals x plus 3. And that's where the x plus 3 comes from. And there's our function. Okay, we get 2 times the quantity, and I'm not sure if you will see all my letters here. And if not, I do apologize, but I'm dealing with a new camera. And right now it's distorting picture a little bit. So all the stuff I've been writing, not all of it has shown up. Okay. But again, to go over it, original stretch by factor 2, we multiply the y values of f of x by 2, getting 2f of x, which is 2x squared. Vertical shift -5, well, we just subtract 5 from the y values. That'll move the graph down 5 units. 2f of x minus 5, which is 2x squared minus 5. K is -5 because k is what we use for the vertical shift. H is what we use for the horizontal shift. Horizontal shift is -3, so H is -3. And now we have the form a f of x minus h plus k. A is 2 as before here, and k is -5 as it was up here. And now h is -3. X minus h is x minus -3, which is x plus 3. So there's our function. Don't have room to write it, but this is called the vertex form of the function. We can see what the vertex is because what we've done is we've shifted the x squared graph has a vertex here. In my class, I use a red dot to represent the vertex. We've stretched it out by a factor of 2. Which gives us this, a taller, skinnier graph. I mean, it's the same width, but it's taller, so it looks skinnier. And then we've moved it over 3 units to the left and 5 units down. Okay, so we move over 3 units to the left. We're 3 units and down 5 units. Now we take this picture here, and I'm going to erase this one. I'll kind of leave it smudged in there so you know it was there. The vertex has moved here. And the rest of that graph window has moved along with it. So our final graph, and it's not drawn very well now, but it kind of looks like this. And with this in the vertex, the vertex started out at the origin, it stayed at the origin when we stretched it, but now we've moved it over to the left and down, so that it's at the point -3, -5. Try to understand that as much as you can. Here in my class, we'll be getting to that soon. Probably start talking about it, maybe even today. Then finally, we have the task of figuring out what the formula is for this graph. Using what we know here. Here's your vertex. I'll even make it red. Coordinates of the vertex? Well, it's on a vertical line that's labeled x = 8, and it's on a horizontal line that's labeled y = 4. So the vertex is at 5, 4. That means that if we had started out with the toolkit squaring function, it would have been in a window about here. Window. Whether you're in my class or not, you can understand that if we make a 4x4 window centered with the lower edge centered at the origin, that's where the vertex is going to be, right in the middle of the lower edge of this window. And if we move over 2 units here or over 2 units here, the square is going to be 4. So we're going to hit the line y = 4. So we have to have this point, and this point. This is the toolkit squaring function. You can draw that any way you wish. There it is. Now for this function, okay, first of all, with the toolkit squaring function, if I drew the line y = 1, and the line x = -1, and the line x = 1, we would see that this graph goes through the point -1, 1, and 1, 1. Graph got a little too fat on that side, so we kind of missed the point. But what you can see is we go over 1 and up 1 from the vertex, right? And on the left, we go over 1 and up 1. So if we go over 1 and up 1 on the vertex, then we have a copy of the squaring function, of the toolkit squaring function, okay? Now, what do we do here? We go over 1 and down 1. What's that mean? Well, that means something that's pretty obvious. This toolkit squaring function has been turned upside down. Okay, so that means we're going to have a negative vertical stretch with a negative, okay? But we don't really have a stretch because we go over 1, we go 1 unit in the y direction either way. So we just put a negative in front of x squared. That's going to do it. Now, there are other ways to see what this function is, but once we know that we're going to be doing a negative x squared, we can see that the vertex goes over 8 units and up 4 units. So right away, we know this graph is AF of x minus 8 plus 4. Now I'm going to lose track of the time if I don't take a quick look. Yeah, we got 15 minutes actually, so doing pretty well. Okay, so we start with the toolkit squaring function, which is f of x equals x squared. We multiply it by -1 so that the graph flips upside down. Then it's going to fit these 3 points. So here is our function. It's -1 times x minus 8 squared plus 4. That's negative of x minus 8 squared plus 4. Let's say we didn't know geometrically how to figure out that a is -1. It's pretty easy to do that. If you just put a window here that's 4 units wide, well, that's what I'm not going to get into that. The other thing you can do algebraically, and this is what I really want to get to, is you can do a little bit of work here. Yeah. This need a way to support these narrow boards kind of in the middle here. I'll have to work on that. So we're back to this one. Okay, now I'm going to have to an alternative. Let me do something different. Sorry for the confusion of the boards, but camera in a new position, and I'm kind of dealing with that. So what I want to do is get this board over here. As far as right as I can. So I can continue what I'm doing here. Okay, you see that by the horizontal shift and the vertical shift, I've got the values of h and k that I can plug in here. Okay. I got the value of a just by comparing the graph in the vicinity of the vertex here with the graph of the toolkit function in the vicinity of the vertex. That's worth doing, but a method that'll work when it's not practical to do that is, okay, horizontal shift 8. We got the toolkit scoring function f of f. Um, where did I get 4? That's sorry, plus 4 here. Vertical shift was 4. Looked at the wrong part of the board. Yeah, just a little more legible. Okay, we're up to that. Now down here, I also said there's a negative in front of this. And told you why in terms of the geometry of the situation. Let's see what you do if you can't see the geometry of the situation for one reason or another. It's too complicated, the function's too weird. Okay. Let's say we know a point on the graph of this function, and we do. We know this point and this point. Okay. It doesn't matter what point. We could use this point or this point, which you can easily enough reason out, or maybe it'd be given that this is a point 6, 0, and this is a point 10, 0. Okay. But I'm going to use this point, which is 7, 3. So we know that the points 7, 3 and 9, 3 are on the curve. The only thing we don't know in this function is x is 8, h is 8, k is 4. The function is y equals a times x minus 8 squared plus 4. We just don't know what a is. If I plug in the values of x and y for a given point, you can pick either point. We're going to pick the point 7, 3. Then our y equals a times x minus 8 squared plus 4 becomes 3, that's our y coordinate. 7, there's our x coordinate. And now we can solve for A. First of all, 7 minus 8 is -1. Do what's in parentheses first, right? And then do the exponent. Multiply A by 1, 3 equals A plus 4. Subtract the equation, or add the equation, -4 equals 4. And we get -1 equals A, or A equals -1. Okay? That's pretty slick. If we'd have put the coordinates of the point 9, 3 in there, that would have worked okay. If we put the coordinates of an x-intercept in, it'll work. Put any coordinates of any point on this curve into this form, we're going to get the value of A, and we're going to get -1. Okay? That's a big deal. And that's what open math tells you to do. And it's exactly what I tell you to do too. After you understand the picture of the situation, then you reconcile that picture with this fairly simple algebraic step. So that's what you got to be able to do. Now, you have an assignment coming up, and let me just pause and take a look at your assignments. Okay, I've just changed the assignment. You won't have an assignment for next time, except to really nail what you can on the present assignment, this whole picture. So I recommend you review that as well as you can, spend the normal amount of time on it. So when you see it in pre-calculus, it's going to be pretty familiar to you, and then you can finish putting it together. Okay? If you're already seeing it in pre-calculus, well, hopefully this explanation helps support your efforts. Okay? So next time we'll talk a little bit about polynomials in factored form. Polynomial in factored form is a pretty simple thing. But when we get into analyzing them, it's very interesting. So that'll be the 3rd chapter, I believe, in the text. And hopefully we're able to stay a little bit ahead of the course just to give you some basic ideas. All right, well, there it is. Any questions?